So we worked with our model. We worked with the lidded container, the hinge lidded container last week. This week I want to go over adding actual like locking latches and such. Because so far they open and close, but that's about it. And especially depending on your clearances, that might not be that snug a fit, or maybe be a little bit too snug, whichever. We'll talk about that as well. So flopping over to Fusion. So last week this modeled this Oreo case to specifically hold two Oreos, just in case. And remember, one of the goals of this is it's not just the case, because the case is it can simply be a lidded container. Now you can have more than single lids, so I don't know if you make it like double doors or anything like that. You make it open up, stuff like that. More power to you. But it is to hold a specific object, simply so that that means that you are locking in and having, if you need an extra component, which could be like this insert. So, like, if your object is a little bit too small for the container, or vice versa, maybe you want something that holds more than one, you need to have some sort of an insert that takes up space so that the object that you were putting in there fits snugly. So, even if it's something, forgot the word, not symmetrical, asymmetrical. There we are. I had to work it through. Maybe you're making it for a tool case that holds like a pair of calipers or something. Obviously, it's pretty well good all the way up here, but then the head changes up, so you would need to make something all around. Now, again, your object does not have to, or your container does not have to be standard symmetrical. I don't care if your object or your container happens to be a round container or sphere or something. This is a model of playing with. This is made from making a shape and revolving it halfway and making two halves of a container, and opens and closes, that also has one of the things we can discuss, a little bead in the center, or in between, which would make it slightly more weatherproof. This one also has what we're going to discuss tonight, which is a print in place snapping tab that clears your object with just enough to snap back in place, but enough overlap to where it would actually lock in place. So we're going to discuss that tonight too. All right. Well, and then one of the other ones is I'll also discuss how I made like the texture pattern and such onto things like this. But the model I work with is the pen case modeled up last class. No, I modeled up the Oreo case. Same diff, same container there. It currently has little thumb tabs on. So the idea is that you could at least just kind of twist your thumbs and it would pop out open. Now, of course, it doesn't actually lock in place yet, and that's what we're going to solve tonight. But since this is a straightforward box, I would like to show more of something on if you were to have made a rounded object or not straight up and down. Now, one of the things we're going to discuss in how to go about modeling some of this stuff is a section analysis. What that is, and it's already applied here, it's under the inspect tool. Section analysis simply allows you to create a cross-section view. Now, that does not change your model whatsoever. It is simply a way to view your model. And what I've done here, you place it in relation to any one of the main plane axes. So the XZ, the XY, the XZ. I just said that twice. Whatever. In this case, cross-section you see between, because clearances are absolutely going to be an issue. So with this model, what I did is made a rich mahogany case that holds specifically two Sharpies. But I also use the section analysis as a way to create the insert that would snugly hold said Sharpie, so it's not just rattling around in there. You can do what you want to do. What this allows you to do is see as it's opening and closing to make sure that nothing is making contact, nothing is intersecting, that sort of thing. You don't have what are currently under two separate components, and you do have to have your lid and base on separate components, not just objects. They must be in separate components in order for the joint tool to work, to actually get the whole thing to open and close anyhow. So with that, we can see inside, we can look across, make sure that, say, like, nothing is interfering. It's like I was making this Oreo case and I was making it round. So obviously making a flat thing, being the hinge, on a round thing definitely brings up issues. So when I zoom in, you can see how this base model, the hinge for the base model, is currently overlapping and intersecting the lid. Now that part I could easily solve by just simply using a combine operation, combine and cut, using the base object as a cutting tool to slice away this partial circle from the lid, and that would clear that up. But that's the kind of things we're going to be working with tonight. Sorry, just had a little spoof there of like, oh no, I do have the microphone on, right? So that's what we're going to be working with tonight. So, all right. Going away from, and this was the stacking Oreo container. I found models for Oreo, so that's what I was working with. All right, so how do you go about dealing with this stuff? Well, we made this lid, we made this container, that sort of thing. And since this is already modeled, we're going to work with this one for now. So I currently made these tabs and such as just extrusions after the fact. They're half circles, they extrude up, but one of the details and one of the ways we were working is adding fillets and such, so that if we go to print these, we don't have to make a whole bunch of scaffolding supports. It's not like it's impossible to use, but you could model an object, one that uses fewer or no scaffolding supports, and it's also stronger. So things like, as we discussed before, hard, sharp angles, sharp edges make for a weak point. A larger curve here allows for the whole thing to be a little bit stronger because, one, there's just simply more material. And again, we're not printing these solid, but a curved object is by design slightly stronger than a sharp angle object. The other thing is this overhang, while it might be a little bit too far outward, but with this heavy fillet here, this curvature, it allows for slicing to occur and without the need for scaffolding. And while it's not so much that I'm worried about wasting a bunch of material, it definitely does add more time to my print. So this is also a convenient way of cutting the printing time. Same thing with printing the hinge that has such a heavy heavy angle on the going up to the hinge part. I won't need to put scaffolding on the back either. Now, obviously, the lid would be inverted when I go to print this. Same deal. Got enough of a fillet here to where won't be an issue. And also on the lid, I made the little thumb tab a little bit a little bit smaller, so it won't be sticking out in space as much. Same thing goes all around. Is that, let me hide the lid and bottom and the pens. I made this insert. And let me put away the analysis, as this would just drop into the case, so that would be printed as a separate object. Plus, if I wanted to change stuff out, I could just print the case as it is, and then I can stick this in, drop this in. And I even used a shell tool underneath to hollow out some space underneath. Now, frankly, 3D printing and standard modeling, like standard manufacturing processes, a hollow space would be great if this were like mold injected. But 3D prints, at least filament prints, they're already hollow anyway. So this is frankly just a little modeling detail. So, or they're not hollow. It depends on, or completely hollow. It depends on the percentage of infill you use. So it's kind of a way around. But it's a nice demonstration on ideally taking up less material. That's all. All right, so let's get back to it. We got the lid, we got the case. I can leave the pens hidden for now because they are currently irrelevant. So what do I want to do to make a latch? Simple latch here. We got the thumb screws, latch and lock, that kind of thing. It's kind of one of the same. I'll discuss in a minute. The idea of a lock would be more of like, instead of like a built-in, modeled in, this is for my mistletoe container. It has the locks themselves move as well as the container housing a mistletoe. Perfect for the holidays. Pen case. There we are. Okay. So the easiest thing is going to be kind of the same approach that we did for modeling the hinge, in that we're going to switch to side view, and we're going to make a sketch smack in the middle plane there, or smack in the middle of your object. It doesn't have to be, but that is more convenient. Again, if you have difficulty grabbing it inside, just temporarily hide one of the objects, like the lid, that sort. But it is important that we discussed activating different components before. Now, I made the pens separate as a separate component entirely than I did the container itself, and the container component houses the two separate components of the lid and base. You can have nested lids, but what I do want to do here, oops, I didn't want to add that sketch just yet. Let me go delete that. Because at the bottom of my timeline, when I switch to auto color mode, you can see the coloration delineation for each of the different components, the green all being that insert I used. So what I want to do is activate the relevant component is the container. Now, if you built everything all in the same not nested, that's perfectly fine. Just activate the whole project. But I'm going to build this in specifically inside the container component, but it is outside of the lid or base. That way, if I need, as we did before in creating the joint parts of that object component, I can isolate each one from one another, the lid or base. So if I do it here, creating a sketch on bisecting the project here on currently on in mine, it's the XZ axis. There we go. Now what I'm going to do is, since I'm basing all of this on the outline of the container, let's do as a projection. Press P or go to create, project, and I want to project the whole body right now. There we go. Hit OK. Now when I go to hide the base, I can see an outline. Oh, I don't want that insert right now either. However, that doesn't isolate the tab since I already had that tab made. You don't have to have the tab. You could do the tab or a latch or and such. So as long as you have one of those, you don't have to have both. But since I already added that to this, I want to build around that. But using the outline, the silhouette here kind of messes me up. So what I'm going to do is I'm going to project again, and I'm going to unhide that base, and I'm going to use specific entities, and I just want to make sure I grab what is just the outline, that angle of the side, not including that tab. Technically, what I could have done is also just done this sketch, moved the history slider before I added this tab, would have been the same deal. But since I didn't, and I'm making it after the fact, there we go. Okay. Now when I go and hide the base, now I also have that line there. That's important for this case. I'd be doing the same thing for the back, but it's irrelevant right now. Okay. Now I have a functioning outline that I can work from. So essentially, to make a locking tab, all I need to do, and we're talking very basic here, let me orbit under for this little like kind of blob thing, is simply an extension that goes from one side and overlaps the other, but it has enough clearance where it'll still move, but it'll have a little protrusion of some sort that would protrude inside the outline of the other object. So what I mean by that, and I have a section analysis here, let's zoom in a little bit. Now you can ignore this little bump because I made that to create like a weather seal on this container. But what I did is it has an overlap. There's a little gap, but then there's a little protrusion that sticks inside of the outline of the other half of the object. And as I move, it does still technically overlap a bit. That is okay, because we're going to make use of the fact that even though we are printing in pretty strong plastic, it is still plastic and it does flex just a little bit. So it would push up and around technically and snap past back and forth. Now the trick is, don't make that overlap too big to where it won't actually go past, or it'll go past and break the tab off. So this is also one of those places where you have to do a little trial and error. Rounded part protrusions work well. A angled protrusion works well, but flat with sharp angles, like 90-degree angles, do not work as well. But you can always round that out. The other part of this is where this model I made, where it has this little weather stripping bit here. Yeah, technically that would perfectly fit. But as we've experimented with 3D printing and such, we know that there is a teeny bit of squish that occurs, a little bit teeny bit of expansion as the filament comes out of the nozzle and it gets deposited down onto the print bed. So it squishes out just a teeny bit. This is not precision manufacturing. It gets real close, but we do have to build in a little bit of clearance. The clearance the clearance allowances that I usually use are about, since we're working metric, usually something around 0.0, I think it was 0.05, somewhere between that and 0.1. 0.1 definitely being on the higher end. If you need, might go all the way up to 1.5. Again, that's millimeters, so it's quite small. But just that little bit of clearance usually is a lot enough to excuse me, to compensate for that little bit of squish. So meaning that if I had printed my hinge here, or if I print this, and currently with this hinge printing all of that stuff, let me turn off the section analysis. The clearance is on this model is no clearance. That little teeny bit of squish might make it to where when I go to print this and put them together, it won't quite fit. So I have to use a sandpaper or filing or anything like that. But if I put a little bit of clearance on there, it'll slip right in. Of course, the flip side of that is that lack of clearance and having to sand and file an object into place allows you to get a really nice snug fit. Whereas adding the clearance in, it might be a little bit floppier than you would like. So that's the kind of part that you have to weigh out in modeling your designs, or trial and error. And hey, if it is a little bit too big, okay, well, print it again. No big deal. Okay, so that's the whole rundown. Let's get back to actually modeling this thing. That all considered, I do also need to make sure that I have the top as well. So let's make sure to include the lid, project again, and I should have done this already. But in this case, all I need to borrow really, and this was really kind of the case before, I just need to borrow that part and the lot. So I could get away with probably just copying just these first couple lines. Oops. Let's hide the lid. Yep, that'll work. Okay, cool. All right, I'm still in the same sketch, yada, yada, no change. So for this, you can use either just draw like by an extension. You could draw this by hand. You could draw it by line, something like that, whatever. We're going to play around with this kind of thing. But if you want to, again, let the program do the work, just use an offset. I'm going to turn off the chain selection because I only need that line and maybe that line. I don't know why it's going back around the bend there, but let's make it at least a little bit bigger. Let's make it a 2 millimeter offset. Sorry, the word fell out of my head. There we go. So this comes off a little bit. You can see how that's going to go. All right, cool. I don't know why I did that, so I'm going to delete that line and delete that. Oop, not that sketch. Delete that line. Cool. Okay. For some reason, if I delete, there we go. Double clicked. Okay, cool. So I just need to make this. If this were a flat section, I could probably just use like a center point center point rectangle, go out a little bit. I don't know. Make it 4, make the other one 10, something like that. Even that could work. So whatever you want to do, really, I'm just going to kind of model this in a little bit more so to match this design. That's all. Delete there, delete there. Okay, so I got this, but this is kind of a little excessive. So let's chop it up. Let's go. Let's decide a line. I'm just going to trying to define how far down I want to go. All right, 5 millimeters seems reasonable. Cool. And I'm just going to use that as a reference line. So turn that into, press X to turn that into a construction line. All right. Now I'm simply going to draw across to close that part of the sketch. And I'll do the same up top. If you want, doesn't even have to be flat. You could make this at an angle or something. Basically, you could treat this like the backside when we were modeling the hinge. Cool, whatever. So I know I'm going to have these sections there. Great. Finish sketch. There we are. Okay. Now for right now, what I can do, like we did before, I want to extrude this, but I want it to make sure that it automatically bonds into this latch and such. So let's make sure I grab those sections. Of course, the problem is now I have multiple stuff, so hide that object. So I just want to make sure I'm grabbing the sections that go across. Problem is since I have kind of a complex shape here, it kind of gets a little obnoxious. Not a big deal. All right. We're going to extrude that. Didn't select all the things. But, oops, I should have done that first. Make sure that you activate the component that you want to attach this to, being the lid. So, even though it's hidden, when I go to select, oops, when I go to press extrude and select those chunks of that sketch I just made, when I start to extrude it, I have the body hidden. Where'd you go? What's going on here? Why is it? What's going on here? It's not extruding. Always something new to discover. What's the problem here? Sorry, give me a second. I'm not sure why this isn't extruding. Okay, sorry about that. Figured out what it was. The sketch that I had built had a bit of an error in it. So what I did is I reactivated the whole container project, went back into the sketch. So edit sketch, just went back in here and made some adjustments and turned a couple of these lines that were there from regular lines into construction lines. So it did not interfere with the sketch as badly. So that should have corrected it. All right, so back to activate the lid component. I want to extrude. And if I have difficulty grabbing that sketch, again, I am also having issues because this tab is here. If you do this like after the fact, or if you do this after modeling the tab, don't. Okay, so I was just trying to get those two pieces. Want to extrude outward. However, it is currently reading it as a cut because it is placed here. So just because I am having to deal with this, you will not have to if you just model this as a latch instead of a thumb catch here. So I'm going to have the start point as an offset, and let's go -15. Just moving it over here a little bit. Now I can start this -20 as how wide I want to make the latch component or the little latch piece of this. That's all. Ideally, you'd be placing this smack in the middle of the model. But since I currently have it as operation join, and I now, even though the sketch is under the container component, I activated the lid component, so it automatically is joining to the lid as part of that component. Hit OK. All right, cool. So that would be a latch. Now let's look at the base. Now, obviously, this is going to definitely cause problems because of the way this object is modeled. Because when I go to open this, look at how much intersect is happening, how much is being overlapped there. So what that tells me is two things. One, I should do this not on a tapered model. But beyond that, I need to shrink the length of this tab is made. So let's go back and just edit the sketch just a teeny bit here. And I should have moved this. I should have had this sketch line way up here somewhere. Cool. So all I need to do, let's just trim that down. I'm just grabbing a line somewhere. Sounds good. Okay. I go to edit that extrusion, take out that chunk. Now we're just having this little section here. Cool. Easier way. I'm still going to have some overlap, but that's all right. I'm probably going to need some of that. So one of the ways you can get around this is an easy way if you're having difficulty with, say, like if you have an inconsistent container, like it's tapered or something like this. Honestly, the best way I have found, base your drawing, your model, or at least this part of this tab, base it around a circle that starts in the center of your hinge. So one more time, let me go back into the sketch. Let me hide these two components because it's just in the way. And I'm going to draw a center point circle starting smack right there where my hinge starts. And then I can just draw outward. Let's see what would be reasonable as a way to clear. So if I bring that circle all the way over here to that center point, hit OK, finish sketch. So now I have that big old circle. It seems utterly excessive, kind of is, but it's way out here. Let me go to finish sketch. Hid the stuff because I had the there we go. My hinge sketch. I don't know why it automatically hid. Let's go back to that last extrusion. Edit that sketch again, edit that feature. And I want to consider that circle line. Just going to deselect just that part of that tab. Hit OK. All right. Now left this kind of seemingly big old chunk here. But when I go to open this, now it does not intersect, overlap whatsoever. So adding that circle as part of your sketch based on the center point of your joint is an excellent way to just very easily consider the clearance regardless of the outline of your container. As long as it is opening based off of that circle, you're good. Now we still have to add a little tab in there, but we'll deal with that. Okay, cool. Got that sketch, got all that yada, yada, yada. Now I can go back and edit that sketch a little bit. What did I show before? In my round container, I made this let me snap back in, section analysis. I used a circle. I have found that starting with a circle kind of gets to be a bit of a makes it a little bit difficult because at some point trying to consider clearances, you're going to have this little point where the circle starts to go back on itself when it gets past the halfway point. So a little extrusion that is instead rounded seems to work a lot better. So let's go with that. So if you want, you could have included this in the original sketch, or we can go back and add it. So once more, we had edit sketch. Okay. Hide those parts because they're in my way and they're just obnoxious. Cool. Now, my sketch is getting a little complex here, so it's a little bit difficult to see, but that's just because I started adding a bunch of other stuff. If you start with that circle and then just kind of build outward from there, this will be so much more simple to work from. Oops. Deleted the wrong line. Cool. Okay. So I need to add something right in here. So let's add a center point rectangle. Cool. Based off of that line, somewhere up here. Honestly, I don't need it to extend very far. So let's say to 1. That's pretty significant. 1 millimeter, at least on this design, should be all right. Tell you what, let's just make it a square. 1 by 1. Cool. All right. Go to finish sketch. Once again, one more time, edit that extrusion. I want to include that little chunk of the tab, join. Cool. Now my model, oops, lost where it was. Now my model just has that little point in there. Great. I'm not going to worry about, since I already know it's going to clear the actual overall tab, but my chunk here is going to protrude a little bit into my design. Good. I want that little bit of a catch. Now, again, you probably should make, if you have quite this tapered model like mine does, you might want to extend it a little bit further, but we'll deal with what we got. I can always make that a little bit longer if need be, anything like that. Okay, cool. So let's hide the base for a moment. And now let's just kind of tweak this a little bit. Easiest way to work is either a chamfer or a fillet. So let's put a couple of those onto here. Whoop, 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 whoop. It keeps snapping my model way over there. You definitely want to put a chamfer or fillet on these edges. Let's go by 0.1, 0.5. Why is 0.5 giving me? Oh, because it's not that far. Let's say 0.3. There we go. You definitely want to add a chamfer, especially to the bottom or the leading edge, but might as well even those out. You could use a fillet as well. Doesn't matter if it's flat or rounded, either one. But again, a sharp edge is going to run into things and is not going to allow it to clear whatsoever. Cool. Okay, great. From there, if you want, you can go ahead and like make any changes to this as you like. So things like if I want to start adding fillets to like add a roundy bit onto the sides here, cool. Why not? Let's extend that out, playing with like we did for the little tab there. Neat. Do there. Let's throw again a little bit more here. Repeat fillet. I want to round that out a little bit more, just so it's a little bit stronger. There we go. It even extended past my original model. No biggie. Okay, cool. I've also found that if you add either a chamfer or fillet, let me hide that sketch. It's just in the way. To this leading edge here, you can kind of get your thumb underneath it a little bit easier if you needed to. So let's add a chamfer to that line also. Let's see how far I can go. Ooh, that'll actually work pretty well if it's still modeling okay. Great. Because now when I go to the side, you can see unhide the bottom. Okay, for the other side. There we go. Even though my little tab definitely now intersects inside, that little bit that protrudes, but it's got a little bit of a back cut to it, I can get my thumb in there and help pull the plastic just a little tiny bit when this is printed. Cool. All right. So how do we figure out clearances and all that kind of stuff? That's where we throw that section analysis down. But my section analysis is way over here. No big deal. All we need to do is edit that analysis. So go to edit feature on that, and it's on a slider. So just drag it back to where it makes sense. Somewhere in there. Now it's getting to where I want. Now I can see my overlap, and I can work with that. Cool. So now what I need to do is make a recess. This is the easy part. But before I go any further, what have I not done? Saved. So add tab. Cool. Save often. Okay. This part's the easy part. I'm going to use a combine tool. Go to cut. I want to, my target body is the bottom half, and my tool body is the top half. Make sure you select keep tools. Otherwise, it'll just delete the whole top. Do that. Hit OK. Cool. Now I go to hide the lid. Now my model, let me hide the section analysis, has that little tab slot in there. Now, again, because I already made this little tab here, I'm going to get some funky results because it's deleting little chunks in there. But honestly, it'll still work because it fits. That little tab, turn the section analysis back on. Oops. Now, as I zoom in, whereas I had an overlapping design here, the colors overlapped, now it does not. One last thing, though, I do want to build in that little bit of clearance, because right now, if I printed this, that little tab is going to be pushed just a teeny bit outward, and it might not snap into place as well. So let me hide the lid, and I want to isolate just that. Turn off the section analysis again so I see everything, but you can still model with the section analysis on, so long as you're not having to grab something that is currently hidden. Because again, Fusion works on what it sees, what is currently visible. Now, what I want to do to add clearance to that is a different version of extrude. It's the first one over here. It's called press pull. Basically, it's an offset face. It's still an offset tool, just like we've been using to make multiple lines, anything like that. The hotkey is Q if you want to use it just on the keyboard. But it allows you to simply modify geometry that's already there, like it says. Not animate because I moved my mouse. So what you can do, go in, select the faces. I want all three of those back ones and also the two sides. So grab that, and I'm going to offset, we'll do 0.1. So what that's going to do, oops, I shrank that. Make sure it's negative. There we go. 0.1, there. Activate section analysis again. Unhide the lid. Now, when I zoom in, I've got just that teeny little gap, which frankly looks enormous in this case, but it's pretty tiny. Honestly, if you feel like it's a little bit too big, go back in, edit history, or edit feature, and let's turn that into a 0.05. Cool, there you go. Now, one little thing here is you might end up with that there. You got a little bit of a catch there. I think that'd be fine. Actually, a little bit snug right there would be fine. And at worst, if you printed this and there was a little bit of an interference, use like an emery board or some sandpaper. Honestly, emery boards are some of the best tools to use for modifying prints, little modifiers, and file that little chunk away. But there you go. Seems very roundabout way of working, but basically all we did was just made a cross section. The only difficulty there was simply that I had already modeled these tabs in, these finger tabs in. All you need is just some kind of projection that goes from one side to the other, that's got a little thing that sticks out and goes technically inside the other object. Again, my round container is a much better example. And this one, what I had to do was, because of how this was modeled, what's going on here? Originally, it was just a cutout of this circle, so a semicircle, and I used like a 0.05 clearance there. However, there was still a lot of material right here. So what I had to do was make a new sketch underneath, and I'll show you this. I had to hide the lid, and I made a new sketch of just this little tab here. There is just a little chunk, extruded it upwards, just so I could push this little bit up a little bit. And you can see as I go back and forth here, all I did is I would just push this material up a little bit using a push pull, just so I had a teeny bit more clearance. Now it was still going to intersect a whole lot though, even with that amount. Again, this is only like this is like a 1.5 millimeter diameter circle, or radius, I forget, sorry. So what I ended up having to do, add a fillet to these two sides, that when complete, round it out. Now I still have just a teeny bit of overlap. That's okay. That will allow my print to work back and forth. Now, one thing about this print here, as I've designed it, I want you to note what I just said before. Sharp angles are weaker than curved edges, or than curved angles. So right here, I've actually accidentally modeled in a very weak point. This print goes back into itself by just a little bit. So I'm creating a stress point as I try to push this past. I'm very likely to break this off. But in this little section in between, if I close this off, modify the original sketch for the tab, and even better is if I add a fillet from the center line to the bottom of this circle, I will make that tab much, much stronger. Same thing for over here. If I add a fillet on the back side here, like I have done with my pen case design, or in this case, a much larger chamfer, same deal. I've just gone beyond the simple right angle, and I just added material to it. It makes for a physically stronger print, a physically stronger design. So there you go. Simple tab, really easy one. We'll take a pause, and then I'll show you how to model a more involved lock. Assume that. Okay, so like I just said, for the sake of time, I will, in a separate video, discuss making the actual lockable latches, the separate components for this. It's basically a combination of the thumb catch latch that we just made for the pen, and the general hinge for stuff. It's just a little bit of both. So for that sake, I wanted to specifically discuss how to work with a hinge on a round body. So all of these so far, all of these models, even my technically rounded container, the hinge was built onto a flat shared surface. So with this Oreo case here, what I did is really the exact same thing, but let me show you what I did here. Activate container, and when I made the hinge, let's see here, I forget where exactly I built this prior to all of that. All right. So what this would have been is I took an outline, a projected sketch of both the lid and container, and then just like we've done before, made my hinge design, based directly on the split line. So I drew a circle out from there. But what I did with this one, instead of for like the pen case and such, where the hinge is floating entirely outside of the body of the container, for this one, I did have it overlap, and it actually begins on the inside edge. So what I did for that is I used a 2-point circle. So I'll go into edit circle. So meaning instead of using a center point circle, go to create circle 2-point, and I started there and drew outward. And it's a 5 millimeter circle. With this one, I was still intending to use a bit of filament fed through, but that's also large enough if you wanted to open up that size and use like a bit of like actual rod or threaded rod or something like that, a long screw, you could totally use that too. But I just made that the extrusion, drew my ears onto there. This one I was playing around and made a more like a big industrial hinge on top. That of course presents problems for printing, but I'll deal with that later. From there, like before, adding the extrusions of top and bottom, activating one component, making the extrusion for one lobe, activate the other component to make the extrusions for those two. Whoops, I didn't mean to do that. There we are. So now both lobes, both sides, adding the joint tool so that it now opens and closes. Oops, that's before I grounded one side. Now with this one, I did also go through creating these knurls on here, but I'll show that in a minute. The main issue with this model is if I go to the top or bottom, you can see that, well, can't see this clearly from the top, but from the bottom, since I'm making straight extrusions, that does not match a rounded surface. So how do you compensate for that? Well, one of the easiest ways is actually using the press pull tool that we just went over. Now you can of course always go back in, modify the sketch, and simply make that sketch of that inner of both side lobes just extend internally within the walls of your model. But the issue with doing that is, what if you have chosen to make the walls quite thin? So this one doesn't, there's plenty of material there I could have extruded outward from and all that kind of thing. But if you made them quite thin, it's a little bit more difficult to deal with. So how I dealt with this, and I can do this before or after the modeling of making those knurls. And in this case, I'm going to do it afterwards. But you could do this before you added features. And just, I'll go through and explain this at another point. But how I did this is I used the coil tool to create an outline, which is this tool. It is essentially a pipe tool, just built into a spiral. Instead, it automatically generates a spiral path instead of you drawing your own path. So it's essentially a pipe tool, and you can select different profiles. In this case, I chose a triangle, mirrored that triangle. Sorry, let me move in the center. Mirrored that triangle, and then, well, I put a chamfer in there. Cut into the surface, and then use the circle pattern tool to make a whole bunch of them. And that's how you make a knurling surface. It's a neat feat. It's a really simple way to make a what looks to be a really complex thing. Anyway, let me snap to current. And that was just showing the Oreos inside, and I'll hide those, yada yada. And I also added a little pin screw here that I imported. I'll hide that. So how do I deal with this? Well, the problem is I joined the two together. So an easy way to fix this, or the way you have to fix this, go back, edit feature, and instead of join, I'm going to make that a new body. So it's still there. It's all good. It's got to recalculate everything. So this is floating. Now I added this onto this component. So I have the box and the hinge. Perfect. Because what I need to do, I'm going to hide the body. And I'm going to use that press pull tool and select that surface, unhide, and I'm simply going to drag that forward a little bit. So what this will do is it just closes all that up. So it simply extruded that surface. And the cool thing is because of the way that the way that the press pull tool works, is it is an offsetting tool instead of just a direct extrude. If I hide the Oreo box, look what it did. Is it even also filled in what was that little half circle there? See, when it was here, it filled in both this surface, even though that's all I have selected. When I pull it forward, it flattened it out to here. So it's a really cool feature to use that is a combination of tools, basically offset and extrude. So go to that, unhide there, and now I would go to join the two bodies together, combine the target body and the hinge tool. Do not cut. I want to join them. Bam. Now that is linked, it fills in the gap. It does, and it also compensates for the knurling and such too. Really cool way to work. Do the same thing for the lid. Hide bodies, just the Oreo box, because it looks like when I did the extrusion for that one, it already went there. Okay, yep, never mind. So yes, same issue here. Oh, this one I think I actually yes, this one I already did the offset face for, or the push pull. So I was able to do the exact same thing there and fill in the gap. So if I go to here, edit that feature, I was able to grab an internal surface where at that point there was a gap, and I was able to grab that internal surface and just pull it forward, and it just filled in the gap there. So now I have a function here. So the issue is I needed to grab this one too. Problem is, what I did is I had them join when I did the extrude. So if you accidentally do that, you can either go back and modify that extrude to where it simply does, instead of join, it could be a new body. See if it kicks back a bunch of errors or anything. Nope. So that simply means that I could use the press pull right there, drag it forward, and then that will fill in that gap. Or what I was able to do for this one, it was already joined. So what I was able to do is zoom in and select within that gap. I was able to actually select one of the surfaces and use the offset tool. So same way, sorry, I keep saying offset. It's press pull. I'm sorry, press pull. Same deal. Just make sure that after the fact, you make sure that you join the two together. Since that one was two separate ones, so let's go to combine, join. I want to join that tool or that part onto body. Hit OK. Recalculate all the things. Unhide, unhide, unhide. There we go. And now it works, and all the gaps are filled in and all that kind of stuff. The one last thing on here was if I go to section analysis, intersects there. Not a big deal. Easy way to fix that too. Last thing, activate all the things. Turn off section analysis just to make sure that it is doing what it needs to do. Sorry, I keep losing where it is. There we are. I need to use the lid as a cutting tool. Wait, let me make sure of that. Yes. See how the base intersects the lid right here? So I need to use a cutting tool. So combine tool, go to cut. The target body is I need to cut into the lid using the base. Make sure you select keep tools. Hit OK. Now, uh-oh, did it do something weird? Now when I hide the base, it didn't do it. Okay, that's a problem. Let me do that again. Oh, it didn't do it. Okay, it didn't do it at all. Okay, hang on. Let's try it again. I'm not sure why it didn't. I don't have an error message or anything like that. So let's try with the section analysis off. Oh, hey, off it on the canvas. Okay, cool. There we are. Okay, so I need to use combine, cut. I need to cut into the lid. Why is it? That's weird. That should be joined. All right, tool body is the base. There we go. Let's try that again. What is going on? It's not doing it. All right, and I'm also not getting any errors. That's very strange. Oh, for some reason there's a split to it. Weird. It made two bodies there. Huh. I've not had that happen before. Or did I accidentally use? No, I used combine. That is really weird. Okay, somehow it made two bodies and it split the body instead of cutting and deleting. So I don't know. There's entirely a chance that my program is bugging out a little bit. Okay. Section analysis done. Where is the other? What? Okay, my program is doing some really weird stuff, but I also needed this to delete into the main body also, so you have to perform a second one. Select the body, tool body, cutting tool is the lid, keep components, there you go. So now what should be is when I hide the lid, yeah, there's a recess now also for that side. So I'm getting some weird results. And see, it's splitting the body instead of deleting it. So I'm not entirely sure what's going on. I think program is getting buggy or something. So hopefully you don't run into this issue. If you do, let me know. That is definitely a new one for me. Don't know why it's doing that. But anyhow, so you should be able to just use one the whole point is you use one object as your cutting tool, just like we did for making the latch there. Use the one object, make the cutting tool, and it simply should delete a area away. I don't know why it's not doing that there. I'm gonna have to go back and do some work on it. So, all right. So, like I said, I will do the locking mechanism, or I'll do the flip locking mechanism on a separate video, isolated from here. I quickly talked about how I made the knurling there. The one other thing I wanted to show you is if you want to bring in objects, um, like this pin that I made or that I used here. So this is actually a model. You could use insert fastener, brings in screws and such, or if it's a tool or if it's a screw or something you specifically want to use, there's another one called insert from McMaster-Carr. This is a company, a fastener company that you can search out your hardware, be that screws, threaded rod, all that kind of stuff. You find the object you want. So in this case, I'll just pick a screw at random. So it was metric. Let's say that was a M3 hole. Excuse me. Let's say I want a socket headed screw. Sure, stainless steel all the time. And let's just say I wanted, I don't know, something, something, something. You simply go to, I had to expand it. Go to the actual product number. This is important. It will automatically import, but we're not using SolidWorks. Scroll down and use the step file. So if you need the reminder, the next step is use a step file. Helps me. Download, give it a second, and it will import the model of the exact type of hardware screw you want to use into your project as a new component, if it actually goes through. Come on, buddy. I think I'm overloading my computer entirely. It pauses for a second. Okay, plops it into your computer. You can simply move it around however you want, orient it generally how you expect to put it. So let's say 90 degrees that way, and I intend to put it in just that way too. So I'm going to orient it 90 degrees that way. Hit OK. And then you can pop this in place using the joint tool. So you go to joint. We're going to use a standard thing. Remember, the first thing you select is what will move. Second thing is where it will move to. So I want the bottom of this face to match up with that lobe. So what I'm going to do, select inside here. Select the inside. Now this is threaded, so it's a real pain to get at. So what you do, mouse over the surface you need, press and hold control. It locks it. I can snap inside of the threads there to the very base. Go over here, second selection. I want it to go right smack in the middle. So mouse over the face, press and hold control in the center. Whoop. It brings it over in place, snaps it right in place for you. Motion is, I'm going to, like it's glued in place, rigid. Animate it, gives you anxiety, or it's just scared. There we go. The whole thing has a screw in there, so you're actually using the hardware you really intend to use. Just an easy way to go. Just a quick thing to consider if you actually want to use dedicated hardware. Save it all out, and we're all set. Okay. Screw this. All right. Have fun with it. Good luck with it. Hopefully you don't run into the errors I'm having. I'm going to have to do some modifying on my own model. I'm not sure which it is. It definitely looks like the program is bugging a little bit. All right. Good luck with it. Hope it doesn't cause you problems.